12-12. So what do we do now? We've got the our three treatments, and we do that ANOVA single factor, which I'm not going to do and bore you with again, but that tells us whether or not these are equal, right? And of course I'm going to take a look at 12-11, okay, whether all three of them are equal. So in this case, I've got these three treatments, and I run my ANOVA, and sure enough, my F is 50.9, so it's huge, okay, and my critical was like we've had in the past, it was 4.26, so I reject the null hypothesis, and I conclude that these are definitely unequal, and you can kind of tell that by looking at them, right? But now I want to, okay, I want to determine what if one or the other may be equal or unequal, okay? If those means might be similar or not, okay, and how do I go about doing that when I have this data for me? Well, I use this formula, and we have this formula is given to us on what page, confidence interval there on page 395, and x1 and x2, or in this case the mean of this one and the mean of this one, and that's the two that we're comparing. I could also do x2 compared to x3, but for our purposes, or for my assignment here, we're doing 1 and 2. Okay, so this says the mean of x1 minus the mean of x2 plus or minus t, and t I find by how we used to find t, but my degree of freedom is my n, which is my number of items in here, okay, which is 3 plus 5 is 8 plus 4 is 12, so my n minus my k, and k being my three treatments, so it's 9, right? And then I'd look that up in the back of the book under the t distribution on page 734 or 35, okay, at that particular two-tailed level of significance, right? So I go down to 9, and sure enough, it's equal to 2.262. And so I've plugged that in here, and I've plugged in some of the other data, right? I mean, my x1 then is equal to the mean of, I got that equal to G12 because it's given to me actually, right? Okay, and my x2. Okay, so these are averages, and this came from my ANOVA single factor, but I could get it from up here as well, right? I could say that I want to figure out what the average of these is, okay, and it's going to be the same thing, right? Or I can take it from my ANOVA single factor where it's given that average, okay? And my treatment 2 average is 2.2. My t, which I looked up again, is 2.262 using the 0.05 significance for a two-tailed test, and that's because I got the plus or minus in there, would probably be my giveaway for that. My MSE, or my mean square of the error, okay, if we remember going back to that, is this number here. Okay, so I don't have to calculate that, which is kind of nice. If I did, it would be this divided by this, and we'd have to go back and redo that whole thing that we did back here on number 7. But I've got it. It's given to me. So I'm going to just plug that in here. Okay, my n is all of these, right, added together, and I can just do the count, okay, if I wanted to, or I can count them manually and plug it in. Okay, my k, right, we know is the 3. Got 3 treatments, so I got 3 for my k. My n sub 1 is the number in this particular one, if it corresponds with my x, right? And the n sub 2 is the number that are in that one, okay? So then I just do the math, right? Okay, my x1, I did the outside here. I did this is equal to my x1 minus my x2, which I have here, minus my x, or the mean, I should say, of each of those. Okay, t I have, so plus or minus my t. Okay, and then I've got, I don't know which numbers I have in here in particular, but I probably have my 1 divided by n1. I've got 1 divided by n1 plus, so I've actually got this inside these parentheses here, okay, which is equal to, let's do that, parentheses, 1 divided by my n sub 1, which I have labeled here, okay, put parentheses plus 1 divided by n sub 2. 1 divided by my n sub 2. Okay, so that's inside the parentheses there. Okay, and then I multiply that, oh, right here, I'm sorry, I multiply that by my mean square of the error. Okay, so multiply this one by this, my MSE times that. So equal to my MSE times what my inside the parentheses was there. So I get that. And then I have to take the square root of that, right? Okay, so it's the square root of that. And I can come up and use the square root function. You guys have seen me do that before, so that's the square root of that. Okay, and then it's t times that, right? So my t value is there. So equal to t times my, okay, so what I've come up with then is that it's my x1 minus x2, which is this 7.466667, okay, or about 7.5, plus or minus t, or plus or minus whatever I came up with here, which is 1.69. So I end up with this is equal to this minus this one. And on the other end, I say this is equal to this one plus my calculated deal. Okay, so I come up with my answer to this equation is that it's between 5.77 and 9.16. Okay, what's that mean? That means that these are unequal. How do I know that? I know that because there is 0 does not reside between these two. Okay, for me to my hypothesis was that treatment 1 and treatment 2 were equal. My alternate hypothesis is that they're unequal, so I'm going to reject the hypothesis, right? And the reason I'm doing that is that in order for me to accept it, I basically have to have one of these as a negative number and one of them as a positive number, meaning that the number 0 would be in between my two numbers. And since it's not, I can reject the hypothesis that these two are equal.